think about the bell work, and today we will review real quick what we have seen yesterday, but I prepared a few slides to explain this post-assessment, okay? Just real quick, we are almost finishing exponential and exponential functions. The curriculum doesn't cover logarithmic functions, but I think I'm going to show something next week to you about logarithmic functions, so at least you know what is it about, okay? I'm not going to talk too much about logarithmic functions. It's not in the curriculum, but yes, I'm going to mention. We will learn a little bit about it, at least to know what it is about. At the end of next week, on Friday, is the due date for the post-assessment. You can work is available from yesterday, so you can work today, you can work tomorrow, over the weekend. 25 questions, all multiple choices, only the topics that we covered during the course, and you have all the tools, all the resources to have an excellent grade on this post-assessment, okay? The objective is to compare with the pre-assessment you did at the beginning of the course, and if you have a good score, let's say on grade level or beyond grade level, is more than 75%, if you have more than 75%, I will give you 100% on the testing this month, this quarter, the fourth quarter. You don't need to do any testing anymore. Even the test you work it is not gonna lower your grade. You will have 100% on the testing. Okay, you just need to complete the 2 quizzes every week, and you're going to be to have an excellent grade at the end of the quarter. This is a motivation, so you can work on this post-assessment and have a good grade. Any questions? And I will talk about it tomorrow again, and maybe on Monday, because it's very important that you go over this post-assessment. You have to work on the school city, and you can start today. Work as there's no time limit. You can work as the time that you need. Spend the time that you need, and the due date is the next, not this Friday, the next Friday, next week. Tell me if you have any questions about this post-assessment. And I'm already getting sad because we are reaching the end of the school year, and pretty soon we will be most of you are graduating, some of you are still in school, but maybe not in this class anymore. I'm already a bit sad. Okay, let's think about yesterday, a quick review. We seen yesterday how to graph exponential functions, right? And we worked on this example. We have one function, f of x equals 2 exponent x, and we have another function, g of x equals, and it's missing here, 1 over 2 exponent x. And we learned yesterday how to graph these functions using the online graphing calculator, right? You have to type the function as y equals 2 exponent x. The other function you can type you can work together. You can represent them together. Y equals 1 over 2 exponent x. Very good, excellent. We represented the functions using the graphing calculator. Now the question is, can we make f of x equals g of x and solve it? If we do this, we will have the equation 2 of x equals 1 over 2 of x, and we have to solve it for x. Find the solution, the value of x that solves this equation. Can we do this? with the help of the graphing tool? That's the question. That's I need your help, and the answer here is missing. So tell me, what will be the answer, the solution for x if we work on this equation here? Maybe we can find the answer by looking at the graph. So send me a message. I will invite a couple of students to help me. Good morning, Cynthia. And let me check who is in the meeting, who will help me. And today I will invite. I'm going to invite Ewell. I'm going to follow the list here. Ewell, and also I will invite Jacob. Ewell and Jacob. Ewell, Jacob, can you find the value of x? Maybe if you look at the graph, you're going to be able to find the answer. Does anyone else have a different opinion? You want to send a message, you want to give your number. Jacob said 0, Ewell 0, agree. And let's have a look. We are talking about the solution for the function f to be equals to the function g. So it's the point that is common to both functions. The point that have both colors, blue and red. The point, the intersection point, which is this one, right? This is the intersection point. And so on. Yes. The answer for x, well, if we're looking for x, we need to look at the x-axis, the horizontal axis. And x equals 0. Perfect. Very good. Very good, Jacob. Very good, Ewell. And if we want to see, to know the value of the functions at this point, then you're going to look at the y-axis. And y is equals to 1. Right? X equals 0, y equals 1. The coordinates of the point is x equals 0, y equals 1. Can represent like this ordered pair. That means, yes, that's right. The solution for x is x equals 0. This is the right answer. Thank you again, Ewell. Thank you again, Jacob. This is the right answer, x equals 0. All right, let's move on. Today we will practice. We will see several applications of exponential functions. Exponential functions have a very a great number of real-world situations that you can apply. The exponential growth and exponential decay. Examples: population growth. We're talking about people in a state, people that lives in a country. We can model the growth of this population using exponential functions. Another application is the growth of an investment. You have money in the bank, the money is earning interest rates, and you can calculate the growth of this money using an exponential function. Another thing about money is debt as well. Mortgage, loan, you can calculate how much this debt will grow using exponential functions. The mass, this is science, the mass of radioactive substances. You can also calculate using exponential functions. So many applications. Another one, growth of bacteria and also viruses is another thing we will apply our topic, the exponential function. I will show a quick example and then we will practice over the quiz, because I have several questions, several situations, and I think it's better to work on the quiz. The example I have here is about the radioactive material. And as usual, when you have these word problems, you might be worried about the context and think, oh no, this is too hard, too difficult. Look, in a sample originally having 1 gram of radium-226, the amount of radium present after T years is given by. But don't worry about the context. You have to focus on the math. You have the function A of T equals 1 over 2 T over 1620. This is the exponent, right? And you just need to plug in the number, the time. The question A, how much radium will be present after 1620 years? So the time equals 1620. We know that time is in years. We have to plug in into the function. So A of 1620 is equals to 1 over 2, plug in here the number T, 1620 over 1620. Simplify, and you have the answer. Most of the time you're gonna need your calculator to find the answer. 1 over 2 or 0.5 grams. Okay, that is the right answer. Very simple, easy. Most of the questions you just have to do that. You have the time, you have to plug in the time into the function to find the amount, to find the population, or to find the amount of money. That's what we will work on our quiz. Any questions? Any curiosities? Anything you want to know about this example? Or any step that you don't understand? Or even any question about, I don't know, the grading, the report cards, and everything you're talking about? The growth is going to be an exponential function, right? We agree with that. And it will look like that. The amount over time is equals the first count, 100, times the exponential function, b exponent t. We need to estimate, we need to find b, okay? If t equals 0, we will have the first count 100. 100 times b, 0 is 100 times 1 equals 0. 100 times 1 equals 100. Is the first count. After 1 hour, we will have 100 times b exponent 1 equals to the second count 110. Now we can estimate the value of b. Divide 110 by 100 and we have b equals 1.1. Okay, so b equals 1.1. Nice. Let's work. Let's check for 24 hours if it works. T equals 24 hours. Okay, so 100 times b 1.1 exponent 24. Okay, this is equals. Type in your calculator and you're gonna find 984.97 and then a bunch of decimal places. It's going to be approximately 985. So good. 1.1 is a good estimate of B. Now let's finally find the count after 1 week. And 1 week is 7 times 24 hours, right? 7 times 24 hours. So 100 times 1.1 exponent 7 times 24. I will bring the calculator because I think this is going to be a huge number. I think this is going to be a large number. 100 times 1.1 exponent parenthesis 7 times 24 close parenthesis, and this is the answer: 199,437,740, and then a bunch of decimals. We will round this to 900 million. So after 1 week, we will have a count of 900 million. And this explains a lot, right? Why we are in this situation now with this COVID, this pandemic. This explains a lot. Is the speed, is how fast the virus grow because of the exponential function, because it grows exponentially. The right answer is a huge number, 900 million. You can write like this, 900 million. You can write like this, 900 followed by 3 zeros. 6 zeros, 6 zeros. Yeah, that's a huge number, and this explains all this thing we are living, all this pandemic, all this situation. This explains a lot. Okay, thank you. You had very good guesses, but actually exponential functions is interesting because of this speed of the growth. Okay, Jacob, let's move now to the quiz. But first, today, as we have seen, we're going to work on applications of exponential functions. And don't worry, Kalia, don't worry about the question and all the story and all the data that you have. You just need to find one thing is the function, and the other thing is the time that you have to plug in into the function. Okay, just need to find these two things. Check the first question. Let me zoom in on the first question. It says nobelium, an element discovered in 1958. It doesn't matter when it is discovered. Has a half-life of 10 minutes. Okay, what is important here is the function, and we have it right here. Okay, so we're gonna plug in the time. For the first question A, the time is equals to 5 minutes. On the function we have the time in minutes, so plug in A of 5 minutes is going to be equals to 0.5, right? And what's this? T over 10. T is 5 minutes. T is 5 minutes over 10. Exponents T over 10. That's it, Kalia. That's it. This is all you have to do. Plug in the time into the function. Use your calculator. 0.5 exponent 5 divided by 10, and find the answer. You need to round to 5 decimal places, so 0.7071, and the last digit we have to round up because it's followed by a 6, right? So 0.70711. That's the right answer for letter A. Okay? Now try letter B, try letter C. You will plug in the time for each one. Let me show here. For letter B, remember you have to plug in the time in minutes. 1 hour is 60 minutes. Letter C, same thing. You have to plug in the time in minutes. 3 hours is 180 minutes. For each one, plug in the right time and you will find the answer using the function. Now give me 1 minute. As usual, I will check attendance. And meanwhile, you try to work by yourselves, and after that we can work together. I can help you out to solve the other questions. At the end, I will show most of the answers, all the answers, so you can compare with yours. For letter H, I zoom in. Letter H. Find a mathematical model that relates the population of Fiji as a function of the number of years. And we need to use this function there. P of t is equals the P0 is the initial count, the initial population is 908,000 times 1 plus rate, 1 plus, and the rate is 0.7%, 0.007, right? 0.7% is 0.7 divided by 100, 0.007. Exponent t, and that is the answer. You will find this option on the multiple choice. Just add 1.007 and you select this option. Okay. For letter I and J, you will plug in the time, because the initial year, the year that is the year 0, is 2009. So we're going to find the time in years. Time is equals. The question here for letter I is the year 2021. And then I subtract to the year 0, 2009. And the number of years is going to be 12, right? Now plug in into the function P of 12. Find P of 12, which is equals 908,000 times 1.007 exponent 12. If you type this in your calculator, you will find the answer. $987,000, and then you're gonna have some hundreds and tens and ones. But the question asks you to round to the nearest thousand, so you just will represent the thousands. 987,000. Okay?